In your reading for this week, you learned about net present value and how we can utilize present value for calculations that help us make business decisions. What I'll be doing in this video is walking through the mechanics of Excel and performing net present value calculations. If you're struggling with net present value or you're unfamiliar with these concepts, please refer back to your reading for a comprehensive review of the underlying methodology. The mechanics that I'm going to be displaying in Excel will likewise apply if you're using a financial calculator. Either a financial calculator or Excel are both acceptable for performing these calculations. You will need to be able to use this functionality in this class as well as other classes in your program. Now let's go through some examples. Our first example is asking us what amount should be deposited in a bank today at an interest rate of 4% to grow to be $2,000 after 4 years' time. What we're solving for here is our present value. Our interest rate, we know, is 4%. The number of periods from today is 4 years, and our future value that we're trying to achieve is $2,000. In this case, we have no payment, so I'll leave that blank. Now in Excel, what we want to do is insert a function. The function that we want to insert is present value. So if we search for that function, PV, and we'll give Excel just a second here to find it. We'll select it, and once we do that, what it does is it gives us input boxes for those different inputs that we just defined. So the rate we determined was 4%. The number of periods we determined were 4. The payment, 0, we don't have payments in this example, and the fair value was $2,000. Now type will come into play when we have a payment stream or an annuity, and in this case it does not apply, so we'll leave that blank. Once we've entered all of our inputs, we'll select enter, and there is our solution, $1,709.61. That's how much we need to deposit today in order to achieve $2,000 after 4 years' time, deposited earning a 4% interest rate. Our second example is going to be one in which we're going to be given the present value and have to determine what the future value is. So a little bit opposite of what we just did. In this second example, if J.J. Moose put $1,000, so that's our present value, in a savings account today, earning 2% interest, what amount of cash would be available after 3 years' time? Our number of periods is 3. So here we're solving for future value. In this example, we also do not have any payments. So we'll go ahead and insert an Excel function formula for future value, because we're solving for future value. So we'll go ahead and search for future value, and once we select that again, we'll be given the boxes in order to enter our inputs. Our rate here, 2%. Number of periods we just identified were 3. No payments, and the present value is 1,000. Again, the type does not apply because this also is not an annuity or a payment stream example. We'll go ahead and select enter, and we'll be given $1,061.21. So had I deposited $1,000 today at a 2% interest rate savings account, I would earn an additional $61.21 after 3 years' time. That would be my account value. The next example is going to be one in which we have a payment stream or an annuity. Here, we're going to determine a mortgage payment. If you buy a house for $300,000, that's the cost today, or the present value, and finance it at 6% interest for 15 years, what would be your monthly payment? So it's important to note that when the payments or the periods are monthly, you need to convert your interest rate in your years into a monthly term. So in this case, since we're solving for months, our interest rate per year is 6%. However, we need that to be a monthly interest rate, so we'll divide that by 12. So the monthly interest rate then is 0.5%. Number of periods then is 15 years times 12 periods, or 180 months. And in this case, future value doesn't apply, so we'll leave that blank. What we're solving for is the payment. So in Excel, again, we're going to choose function. In this case, because we're solving for payment, we'll search for payment, which is PMT. And when we find that in our list and select it, again, we'll input down below our various inputs. So the rate here is 0.5%. The number of periods we determined are 180 months. Present value is 300,000. Future value doesn't apply. Now type does. In this case, and you can see in your Excel box, if the payment is at the beginning of the period, you're going to select 1. And if the payment's at the end of the period, you're going to enter 0 or just leave that blank. In this example, we noted that our payments were due at the end of each month. So here, we can just leave this blank for type, or we can enter 0. And that's what I'm going to do, is just enter 0 in this example. So there we go. Our payments will be $2,531.57. That's our monthly payment on this mortgage. Now let's go to the next example. In this example, Kate bought a new machine and agreed to pay for it in equal annual installments of $4,000. So in this case, we know our payment is going to be $4,000. She's going to make those payments at the end of each of the next 10 years. So here we know 10 years is our period, and we also know that she's making the payments at the end of the year. So that tells us it's an ordinary annuity. And again, when we go into the formula for Excel, we're going to make sure we enter the type as 0, or we're going to leave it blank. We're going to assume a prevailing interest rate of 8%, and we're trying to determine how much she should record the cost of this machine. So we're trying to determine what is that present value. So let's go ahead and solve for present value in Excel. Again, entering the PV function. So let's select present value, and we'll go ahead and put our inputs in. In this case, our rate, 8%. Our number of periods, 10. Our payment is $4,000. Future value does not apply. And remember, the type we said was going to be 0. So when we go ahead and look, enter and select enter, our answer is $26,840.33. That would be the cost of the machine, and that's what we would record on our books for that machine based on those payment streams and interest rate. Let's look at the next example. In this case, Amazon is purchasing a bulldozer. The equipment has a price of $100,000. The manufacturer has offered a payment plan that would allow Amazon to make 10 equal annual payments of $15,582. And the first payment is going to be due 1 year after the purchase. Here, we want to know how much interest Amazon will pay. So you'll notice we were not given an interest rate. What we were given is a present value of $100,000. We were given a payment of $15,582. We're also given a term of 10 years, and we're solving for the interest rate. So when we go into Excel to solve for an interest rate, we're going to select the function again and search for rate. And when we find the rate function in the list and select that, that will allow us to enter our inputs in order to determine what the interest rate is. So the number of periods we just determined were 10. The payment, $15,582. Present value, $100,000. Future value doesn't apply. And because its payments are due 1 year after purchase is when they start, that would be at the end of the first year. So our type, again, as it's been, is 0. So when we select enter, you'll notice that we get a pound number sign. And the reason is because in this example, because we've got present value and payments, one of these numbers has to be negative. If you notice in the prior examples we had, when we entered the payment, we were given the cost of the machine was negative. And when we were given the present value as a positive number we entered, we got a negative payment. So one of the numbers has to be negative in order for Excel to calculate it correctly. So we can just go back in to our formula and make the payment a negative, since that's going to be a cash outflow. When we do that, we now have the answer, 9%. 9% is the interest they're going to be charged. That's what the manufacturer is going to charge for interest. What we're going to do is compare to the 8% from the bank And when we compare those two, we can see that the bank has a lower rate. So we're going to choose the bank loan of 8%. Our last example relates to a new machine that costs $75,000. It has an estimated salvage value of $5,000 at the end of 5 years. So if we spent $75,000 today, we know that at the end of 5 years, or we think at the end of 5 years, the salvage value will be $5,000. If we buy this machine, it would save us $20,000 per year in reduced operating costs and expanded production. If the appropriate rate is 6%, would it be worth buying the machine? Let's figure this out. So we know that if we spend $75,000, we're going to get two cash streams. We're going to get $5,000 at the end of 5 years, and for the next 5 years, we're going to get $20,000 per year. So let's fill in what we know. Because this $20,000 is a payment stream, or recurring annuity payment, we're going to enter that in for our payment. We know that in 5 years, we're going to get a future value of $5,000. We also know it's going to be 5 years' time before either of these cash flows occurs. The $20,000 though, because it's a payment, will occur every year over 5 years. And our interest rate is 6%. What we want to know is what's the present value of those cash flow streams. So if we go ahead again and enter a present value function here in Excel, we can actually just select it from our list, and we'll go ahead and fill in our inputs. Our rate in this example is 6%. The number of periods, 5. Our payment, $20,000. Again, that's just the annuity cash flow stream. Future value, $5,000. And if we go ahead and enter this, we'll see that the present value of those two cash flow streams is $87,983.57. That's the cash inflows from the purchase. We're going to compare that to $75,000, which is the cost of the machine. What we'll note is that we're going to want to buy the machine because the benefit of $87,983.57 is greater than the cost of $75,000.